Okay, so the question is how many words can be formed from all the letters of the word daughter, right? So daughter has how many letters? 1, 2, 3, 4, 5, 6, 7, 8. So we're gonna ignore, we're gonna apply complementary counting over here. And the reason I say that is because it seems too hard to count how the vowels are gonna be split apart from each other. But there's definitely a way to count it with the vowels all bunched up together next to each other. So the way we're going to go about it is try to find the total possibilities of arranging the word daughter, and then the letters in the word daughter, and then try to find out the ways that all vowels are bunched up together, because such that all of the vowels never come together. So we're gonna have that, and then we will subtract. So for daughter, there are 8 letters. And so we have 8 blanks, 1, 2, 3, 4, 5, 6, 7, 8, I believe. Yeah. So it's gonna be a permutation, because remember the permutation is so it's gonna be 8 letters. So n equals 8. And you have to pick 8 of those letters and rearrange them. So r equals 8. So if you remember the formula for permutations, because remember arrangements matter, they're asking how many words, so arrangements matter, and so it would be permutations. Order does matter. And that would be 8 factorial divided by 8 minus 8 factorial. So that's 8 factorial over 0 factorial, and that's 8 factorial, because remember 0 factorial is equal to 1. If you calculate 8 factorial, that would be 4,320. So that's our total. Now we have to find the possibilities that all vowels never come together. All vowels come together. So all vowels together. And here is where I'll show you a sort of trick. So if all vowels are together, pardon my spelling, the vowels are A, U, and E. So first of all, we're going to bunch these together and treat them as one letter. So we're going to call that the vowel, or we can call that V, right? Short for vowel. So D, G, T, R, E, T, R, and then we have V. So we have actually 6 letters to arrange now, because we're treating A, U, and E as one letter together. So now if we apply the same principle, so it's like NPR, it's n equals 6, and then divided by 6 minus 6 factorial, so that's 6 factorial over 0 factorial, so that's 6 factorial, and that's equal to 720. Okay, but the only thing is within V is, if you open up what V is, it's A, U, and E. But if you can arrange this in multiple ways, right? You can have A, U, E, you can have A, E, U, and each of them would lead to a different arrangement. So you need to account for that. And the way you're going to account for it is you're going to do an NPR on this as well. And it's going to be 3 factorial divided by 3 minus 3 factorial, because there's 3 letters, A, U, and E. And so it's going to be 3 factorial, and that's 6. So we want, in this case, we're going to apply the multiplication principle because we want an arrangement of these, and we want an arrangement of the vowels within the V. So we're going to multiply the 2 of them. So 720 times 6. So that's 4,320. So now you subtract, you do complementary counting. So it's 4,320. So it's a total minus 4,320. 40,320 minus 4,320. That's 36,000. So that is a lot of counting to do, 36,000. There's no way we would get that in the time. We might not even get it right if we counted each possibility such that all vowels don't come together. So that's how you solve the question. So we applied complementary counting here. We applied permutation, so NPR, and we applied the multiplication principle. That's really important. So the next question is the little 12 basketball league has 2 divisions with 6 teams in each division. Each team plays each of the other teams in its own division twice, and every team in the other division once. How many games are scheduled? So I'll give you some time to solve it, and then we'll come back and discuss.